Hello, engineers and otherwise curious minds. If you're watching this video, it's likely because you've purchased an engineering projects kit as part of your engineering projects course, hosted at CU Boulder's Integrated Teaching and Learning Laboratory, or ITLL. In this video, we will rummage through our new box of fun and interesting electronics, and run some of our components through some quick tests to ensure that they are configured correctly and ready to be used during our upcoming skill building workshops. As you're opening your box, please remember that the Engineering Projects Kit website is your one-stop shop for everything to do with this kit. In addition to the troubleshooting guides and content gallery, it includes all sorts of helpful content that will help you make the most of your new kit. Now, let's start with this thing, the solderless breadboard, a useful device for organizing your circuit as you prototype and test. What's special about a breadboard? Well, nothing. It's just plastic and small bits of metal arranged in rows and columns. This allows you to arrange and rearrange the components of your circuit as you iterate your design. Next, let's pull out our ribbon of male-to-male jumper wires. Peel one off. Satisfying like a Twizzlers, isn't it? You'll notice that the ends of these jumper wires fits nice and snug into the terminals of the breadboard, as well as the terminals of many other components in your kit. These wires act just like those rows and columns in your breadboard. Use them to conduct electricity between the components of your circuits. But where do we get that electricity? Well, for us, it will be from a battery pack. This battery pack uses 4 AA batteries to output approximately 6 volts from its barrel jack connector. Make sure that the batteries are facing the correct direction, as indicated by the stamps inside of the battery's cradle. This is great and all, but how do we get that electricity to our circuit? Again, we have a solution for that too. It's like we thought of everything. The barrel jack connector has 3 little legs that fit nicely into the terminals of your breadboard. Plug it into your breadboard so that each leg of the barrel jack connector is in a different row of your breadboard. Now, those rows can be connected to your circuit using the jumper wires that we unpacked earlier. Next up, let's open these 2 bags of tiny beans with wires attached. But these are no ordinary beans, these are resistors. Resistors are used to restrict and regulate the flow of electricity through a circuit, and they come in many different sizes and strengths. You have 2 different sets of resistor strengths in your kit, 330 and 10,000 ohms. You can tell which one is which by noting the colorful bands wrapping around the resistor bodies. Try decoding those color bands by Googling the term resistor decoder. Speaking of resistors, we have a few special resistors in our kit. This is called a photocell, and it's effectively a resistor whose resistance changes when in the presence of light. When it's in the dark, it's at its strongest resistance at 10,000 ohms. Cool. The second special resistor that we have is called a potentiometer. It's a variable resistor whose resistance changes by turning the knob. At maximum, ours is a 10,000 ohm potentiometer. Moving right along, let's grab our so far unassembled push button switches. Think of these buttons like spring-loaded disconnect switches. When you press the button, the legs of one side of the button are connected electrically, and when you don't press them, they are disconnected. These are great for adding a human interface to your circuit. But what if instead of using your finger to flip a switch, you'd rather program a computer to do it for you? Introducing the transistor. This revolutionary semiconductor acts like a tiny electrically controlled switch, and it's the reason we live in the technologically advanced world that we find ourselves in today. Go ahead and remove the paper from its legs. Before we move on, a quick warning. This transistor shares a shell, or package, that looks nearly identical to so many other electrical components in the world. It'd be a shame if we accidentally mixed up your transistor with, say, a temperature sensor. So, how can we differentiate it from its doppelgangers? Look closely at its flat face. You should be able to see the designation BC337 printed in tiny letters. A quick Google search will produce a datasheet on this specific part. Next, this grain of sand? This is a diode, and while it's very small, its job is to act as a one-way electrical valve. Push electricity through it in one direction, and it acts pretty much like a normal wire. But reverse the direction of the electrical flow, and suddenly everything stops. Pull off those paper tabs while we're at it. Speaking of diodes, how about a light-emitting diode, or LED? Sound familiar? They, like the normal diode, act like one-way valves. But for LEDs, something spectacular happens when you push electricity through it in the correct direction. They illuminate. But how can you tell which way is the quote-unquote correct way? Notice that the legs are different lengths? Let's keep this train a-rolling and bring out our DC brushed motor. These little motors can spin very quickly when connected to power. DC motors in particular are designed to spin at speeds determined by the voltage that's applied to them. But, and this is important, while it's tempting to spin the rotors of the motor, this can damage your circuit. Do not backdrive your motor. While we're on the subject of motors, let's check out a different type of motor, the servo. A servo is in fact a motor, but rather than spinning continuously at a given speed, servos point in a specific direction. You can see how each of these motors might have unique applications depending on the type of motion you'd like to use in your circuit. You'll also see that your servos come with plastic knobs called horns. Try affixing one of these horns to your servo's rotor using a tiny screwdriver. Again, just like the DC brushed motor, do not backdrive the rotor of your motor. Backdriving turns this motor into a small generator, which can push current through your circuit and destroy sensitive components. Almost finished here. Let's pull out the biggest component of our box, the digital multimeter. This device is like Batman's utility belt for all things electrical. It can measure all sorts of electrical phenomena, and it is crucial for analyzing and debugging any circuit. You'll need to remove it from its packaging, but when you do, you'll also need to install its battery and probes. Let's install the battery first. Using a small Phillips head screwdriver, unscrew the battery cover and install your 9-volt battery into its cubby. Turn the dial in the front to ensure that we've got power, and then replace the cover. Next, let's attach the cables. For now, we'll connect the red probe to the terminal labeled MAV Omega, and the black probe to the terminal labeled COM. To test that everything's working, turn your dial to the position printed with this icon. Then, touch the probes together. You should get a beep. You can stow your multimeter by turning the dial to the off position and wrapping the probes around the body. Finally, we've reached the end of our kit. the only remaining component is the little red circuit board. You'll hear it called a breadboard, but more generically, this is our Arduino Uno board. It is a programmable microcontroller, which means it's like a tiny little computer brain, and you get to tell it what to do by programming it. To ensure that you're ready to use this device, we'll need to connect it to your computer and install a programming application called an IDE, or Integrated Development Environment. Using the USB Mini B cable included in your kit, connect the Arduino to your computer's USB port. You may need an adapter if your computer does not have a standard USB port. You should see a bright green light illuminate. Once that's ready, let's move over to your computer. To find the Arduino IDE, open up your web browser and search the term Arduino Download. Click on the first link and choose the download option that matches your computer's operating system, the first in the list for each. Once that downloads, install it to your computer. Now, let's open that Arduino IDE. Once opened, let's first make sure that we're looking for the correct type of Arduino board. Go up to the Tools drop-down menu and hover down to Boards. There are a lot of options, but we're looking for Arduino Uno. Next, go back up into Tools and hover down to Port. Here, we're trying to find which of our computer's USB ports our Arduino is connected to. The thing is, you may have lots of options, and they'll be named differently depending on your computer's operating system. If you're using a Windows machine, your ports will be named COM, and if you have more than one option, try starting with the highest numbered COM option in the list. If you're using a Mac, you're looking for a weirdly cryptic string of letters, TTY USB serial. And if by chance you can't find the correct port, or the port menu is grayed out entirely, you may need to manually install some drivers. Just be sure to restart your computer after you've installed them if you decide to go that route. Now that we've configured our IDE to target our Arduino, let's actually upload some code. Back in the main space, you'll see that the IDE opens with a default code template. This code will do, well, nothing. And that's alright. We're going to upload this code now so that when you go to take the Arduino workshop with us, you'll be starting with a blank canvas. Up in the left corner, there's a green checkmark icon called Verify. When you press this, the Arduino IDE will run a process called compiling, where it will check to ensure that the code that you've written doesn't have any errors. If errors exist, they will be written out in orange in this debug window at the bottom. And if no errors exist, you'll see Done Compiling. Our code has been checked, now let's upload it to the board. Press the green arrow button named Upload. You'll see the IDE run the compiling sequence one more time. Then you'll see your Arduino shine a tiny light show as it indicates that new information is being installed to it via USB. When it's done, you'll see the word Done. And that's it. I sincerely hope that you enjoy working with the kit that we've curated for you. If any issues come up, just remember that the kit's website has everything from troubleshooting guides to bonus parts and tools lists that you may find helpful. We've even got a list of activity guides to help you spur your creativity and learning using the parts in this kit. And of course, if you ever have any questions, please pay us a visit at the ITLP. We live for hands-on learning, and we can't wait to see what you create.